Hi, in this video I'm going to talk about Std Chrono library in C++. The Chrono library defines three main types: time points, durations, and clock. Let's talk about time point. Std Chrono time point represents a point in time. What does that mean? Suppose that we have this line that represent the timeline, and if we have a clock that has a start point or epoch, usually in Unix system this is the value of the starting point. And so Std Chrono time point is any point in this line. This point is the current time, or the time now. So here we have future values for time points. Maybe we have time point tomorrow at any point, or in any point in the future. Also we can have any point in the past before now. So any point in this line is called a time point. Std Chrono duration represent a time interval. That means any time intervals, for example 5 hours. This is how can you do it in Chrono. 20 milliseconds is time interval or duration. 3 seconds or any other time interval. The third thing implemented using this library is clocks. Clock consists of starting point and a tick rate. For example, a clock may have an epoch, and an epoch is starting time point, and a tick every second. Both of them compose what's called clock. There are mainly two types of clock in Std Chrono. The first one is systemic clock. Systemic clock is like the wall clock time. It represents the system-wide real-time wall clock. May not be monotonic clock. So this is the clock you have in your machine, and it's not monotonic because you can change that time back or forward manually, or if it's synced with some remote server, so there is possibility that this time can be changed or jump at any moment. This is why it's not monotonic. The other type of clocks is steady clock. This one is monotonic clock. The time points of this clock cannot decrease as physical time moves forward, and the time between clock of this clock is constant. The clock is not related to wall clock time and is most suitable for measuring intervals. So the steady clock is similar to stopwatch. When you click it, or when you start it, it keep increasing, and there's no way to change its value. Usually it's used when I want to measure interval, like execution time of a function. Third type is high resolution clock. This is just an alias of either type of the above, so you have to use the first one or the second one. Here is an example of what we mentioned before about Chrono library functionalities: time points and duration and clock. in the left side we have some includes. So this is actually like on top of the main. I'll just put it in the left side so it will be easy to show. First of all, in order to use the Chrono library, you have to include a library called Chrono, as you see in this line. And if you want to skip using Std Chrono with every function call or variable in Chrono library, you can use namespace Std Chrono. Here I mentioned most of the time Std Chrono just for clarification. This is function is just to print time point. So if I have a time point defined using Chrono library, how can I print it in a nice format like this? So I have first to change it to time t. Time t is defined in the C time library, and so it changed. So to time t, it will convert the Chrono time point into time t type, and then I'll be able to print it in nice format using the ctime function, which is also in this ctime library. Here I have function. It's just do sleep for 2 seconds. Not 2 seconds is time duration in Chrono library, and in order to use this notation to us, I have to use Chrono literal. I think this is with C++ 14, and so to do this to us, you have to include or to use this namespace Chrono literal, and this function is just for to sleep for 2 seconds. Here in the main function, the first line is defining time point using Chrono. So this is how I define Std Chrono time point. You can skip Std Chrono here because I added this line here. And so time point you have to define which type of clocks, either system clock or steady clock. And this is just the name of the variable, call it now. And which time point I want is retrieved by this function now. It means the current time point. And if I pass this variable now to print the time point, it will print the current time. And so now represent Chrono time point. Now I can add to this time point any duration. Here how you can define duration of 5 hours. You can use parentheses or you can use brackets. So this statement say add 5 hours to the current time point. So if I do print time point now, you can see it added 5 hours. Instead of 16, now it's 21. So it's allowed to add time duration or to the time point to compose, and the result will be a new time point either in the future or in the past. Here is another example. saying now plus equal 1 hour 30 minutes. And remember, to use this notation you have to compile with C++ 14 and you have to use chrono literal. So now plus equal 1 hour and 13 minutes. I added 1 hour to 30 minutes to this. The result will be this in this line. And now I'm saying give me the time point 24 hours in the past. So as you see here, we have February 9 instead of February 10. So the difference between this line and this line is like 24 hours. Now if I want to define my own type, remember we have hours, we have minute, so I want to define years, and this is a new type. I think it exists in the new C++ 20, but here is how can I define it manually. So using year, and years I'm defining time duration. Time duration needs two things: the type, either long or integer or unsigned integer, and here we have the ratio. This means that this number is in each year how many seconds it represents. So this is the number of seconds in each year. Now if I say 1 year, it's correctly define it as 1 year. So for example, now minus 100 years, it will return time point that's in the past with 100 years. As you can see here, 1922, while the current time is 2022, so the difference is 100 years. Now we want to measure the execution time of function func. This function, remember, it's only sleep for 2 seconds. So before the function I define start point, and I'm using the steady clock. It's more accurate in measuring the intervals. And after the function finish, I have the end time point. Remember, here I can use the auto keyword, and the type will be implicitly determined based on the return value from the function now. So start is a time point, chrono time point, and end is another time point after the function finished. And end minus start is duration, which represents the execution time of the function. But now I need to define which format I need this duration. Is it in hour, in seconds, milliseconds, nanosecond? So here I'm saying I need this duration in seconds. This is why I'm using duration cast. And so the execution time now it has time duration of type chrono, which is 2 seconds. Now to get or to retrieve primitive types like double from this chrono type to seconds. I can't do cout directly, so I have to use the function count. So time interval execution time dot count will return 2, and so execution time is 2 seconds. Here I define another duration in variable called a. This variable has 89 seconds. If I try to do a plus equal 1, it will throw an error, and it's because the 1 is not clear if it's 1 second, 1 hour, or 1 minute. So to overcome this problem, I have to do it explicitly 1 second. So a plus equal 1 second. It means a now is time interval or duration, which has the value 90 seconds. Now if I define new duration using milliseconds, so p equal a, this will pass the compilation because I'm assigning a, which is of type seconds, to p, which is of type milliseconds, and this downward casting is implicitly allowable because there will be no loss of information when I'm doing the casting, so the compiler will allow this. While if I'm trying to do C minute of type minutes, convert A, which is of type seconds, to C, like convert seconds to minutes, the compiler would reject that because you might lose some information, because 90 seconds will be converted to 1 minute, because inside the minutes the type is long or integer. So 90 seconds will result in 1 minute, and if I want to force this conversion, I have to call the duration cast and duration cast to minutes. So as you see in the results now, 90 seconds equal 90,000 milliseconds and 1 minute, and I lost half a minute because of this forcement of casting. In order, if I want to have exactly 1.5 minutes, I have to define my own type duration. So here duration, and I give it type double, and 60 it means 60 seconds, so each minute is 60 seconds, and it's now like how many minutes. This new type is defining minutes in double and not in long integer. So because I'm converting second to minutes, but minutes of type double, so I will not lose any information from this casting. This is why the compiler accepts this line or this casting implicitly. And as you can see here, 90 seconds equal 1.5 minutes. Here's another example how to use Std Chrono with timestamp. Suppose that in your application you want to save some data with timestamp, and you need this timestamp in double format, which represent seconds. So here, first of all, I define this new type of data or of duration, and I say this duration type is double and ratio 1. So each it means that this is n seconds. This is my name of my type name, d seconds. And also I define the new time point. The new time point takes the clock, system clock, and the duration type, which I defined in this line, these seconds. And here I implemented a class that you can use everywhere in the application. This class is just a wrapper that has two time point to timestamp. This is it has extra p, so time point to timestamp. It takes time point and convert it to double. So this function, to do that, the time point have to call this function time since epoch, and these two return interval. Time point to time since epoch will return a time duration, and to have this time duration in double format, I have to call the count function. And so timestamp now in double, and it's in seconds. And I can do the opposite here. I'll take double timestamp and change it to time point. To do that, again, use my new type, the seconds duration, and it take the timestamps, and time TP, I'll change it to duration. Sorry, so first of all we change the timestamp to duration, then from duration change it to time point, we return the time point. Now it's just a wrapper over the function. It's a system clock now. You can use it directly, or you can use it through this class. Here I'm defining clock of my type, clock wrapper, and time point 1 is the current time. And to have timestamp, to use an IO operation, either to save a file in the disk or to print into the screen. So timestamp 1 in double format, I call time point to timestamp, and I give it the time point, and this is the value of the timestamp. And here I define a new time point, which call the converter timestamp to time point, and this is, as you can see, the function is very accurate. So if I do equal between the two time point, it shows they are exactly equal, which means I didn't lose any information from this conversion. And also if I do the conversion again to timestamp from time point 2 to time stamp double, you see it prints the same old value. Here are some guidelines of how to use std chrono in your application. First of all, avoid use .count and time since epoch function unless you call for IO operation. So in all over your application, try to have time points not of type chrono and not of type double or integer, or because by that you will avoid a lot of inconsistency or any error that might happen because of this conversion. So try as much as you can to avoid count and time since epoch unless you need them to do IO operation. As we saw in the last example, if I want to save a file with timestamp in its name, this timestamp I need it in double formats, then I have to call since epoch and count function. Or if I want to print the value in the screen, so I can call count function, otherwise there's no need. Second thing, avoid using duration cast and time point cast, because if you do this force explicit casting, you might lose some of the values. So when you call duration cast to cast 90 seconds into minute, the result will be 1 minute and you lose some part of the value. Because of those two things, you might have a lot of compilation errors, so try to fix these compilation errors instead of forcing using count or duration cast, because at the end, after you fix your compilation error, you will avoid any possibility of runtime errors. The last thing is use steady clock instead of system clock when you calculate execution time or interval. It's because the steady clock is monotonic and it's more accurate in calculating the execution time than system clock. That might cause the system clock you can't change its time forward or backward. That's it. Thank you for watching.